Alright guys, here's your video lesson for today. We're going to be doing a little bit with what's called geometric mean, which is going to be setting up a proportion and solving. And then we're also going to talk about similarity in right triangles. We're going to talk about my good friend Parachute Man. Get excited. So first off, geometric mean is a comparison of two numbers a and b such that a over x is equal to x over b. That's how we're going to set up all these problems. So if you look at the first example here, if I go to set this one up, it's just going to be the first number, 2 over x, equal to x over the second number, 20. Cross multiply, we get x squared. Make sure you get that. X times x is x squared. Then 2 times 20 is 40. And then to solve all of these, we have to take the square root. So we're going back to what I had left on the board for your weekly review, which is going to be due on Tuesday. You have to look at your perfect square numbers. So we're looking at 4, 9 is 3 squared, 4 squared 16, 5 squared is 25, 36, 49, ... We're looking through that list of numbers to see how we can break apart 40. So 4 goes into it 10 times. And then if we simplify, the 4 can come out and becomes 2. I can't take the square root of 10, so it has to stay in. So you get x is equal to 2 radical 10. So each problem you're going to set up the proportion you're going to solve, and then you'll have a little bit of work to simplify the radical. If we look at number 2, that would be 3 over x is equal to x over 48. Again, please remember x times x is going to give you x squared. We're going to see that a lot in the problems that we're going to do for the rest of this week. So just make sure that you're doing that. X times x is x squared. 3 times 48 is 144. Take the square root. That is actually a perfect square, so that's going to come out just as 12. You can always check that first to see if they are a perfect square. If they are a perfect square, you can just simplify it. You don't have to break it apart. Alright, number 3 would be 3 over x equals x over 21. X squared is equal to 36. Take the square root. Let's see, we can break that into... check your list over here again. 9 goes into that 7 times. Make sure you're trying to start with a number from the list. It just makes it so it simplifies correctly. And you get 3 radical 7. If you want to take a minute and pause and take out a piece of paper and just try this next one on your own, I suggest that. And then I'm going to work through it in 3, 2, 1. So it should be 8 over x is equal to x over 6. Cross multiply, we get x squared is equal to 48. And then I have to take the square root. And again, we're looking at this list. Well, 4 goes into 48, but there's actually something bigger down the list. It will save you a whole lot of time if you go with the something bigger. And that's what I had on the board on Thursday. So I'm going to break it into 16 and 3. Square root of 16 becomes 4, radical 3. If you go with the 4, you end up with 12, and 12 still has another 4 in it, so you'd have to keep going. Just make sure you're completely simplifying these. Alright, now we're going to look at how this applies to what we're going to talk about today with triangles. So what we're looking at today is when you draw an altitude in a right triangle, so you end up with a picture like you see here up at the top. The key to these problems, these parachute problems as I'm going to call them, is that you have to see those two right angles. We have a right angle here as the right triangle, and we have a right angle when the altitude drops down. It says that the altitude to the hypotenuse of a right triangle divides the triangle to two triangles that are similar to the original triangle. So it also, if you looked at your book, would talk about the geometric mean of certain parts, about the altitude being the geometric mean of the two legs of the right triangle, or something like that. But it gets kind of complicated. So instead of doing this the complicated way, or as you see in the picture, they've pulled out this triangle, they've pulled out that triangle. Instead of doing that for every problem, I'm going to introduce to you a guy I call Parachute Man, and he's going to help us to set up all these problems correctly. And I'm going to prove to you that they're correct by setting them up, and then we're going to look back at that picture at the top. So, Parachute Man, how this works is he's going to start at that big right angle. He always starts there. The hypotenuse ends up being the ground. So sum of Some of your problems, you're going to have to turn your paper a little bit to make sure that your hypotenuse ends up being the ground down here. What happens is he's going to have a side that he falls down. Whatever side that is going to go in that geometric mean position. So the same place we were putting x in the last ones, that's going to go there. And then he's going to have two distances he walks. So distance walk number 1, distance walk number 2. So let me demo here what's going to happen. So he's jumping out of an airplane, and he's going to, for the first one, we're going to say he's going to fall down CA, which is this first side. So he's jumping out of an airplane. He's always going to fall down one of these sides coming down from the top. You'll know which side in a problem because it will be labeled, and it'll be the side you're probably trying to find. So we're just going to start by saying he's going to fall down CA, so we can start setting these up here. So that distance is going to go across from each other. And then what happens is he falls down to that point that's on the ground. So he's going to come right down here. And then the rest of the story turns out that the other two sides he didn't fall down, so he fell down this purple side right now. Those other two sides that he didn't fall down turn into ladders, so he can get back up to the plane. I know it's not 100% accurate, but this is going to turn it into a ladder. That's going to be his first distance that he walks, which is from A to D. And then this turns into a ladder all the way across to get to his other rescue ladder. You have to give both distances that he would have to walk to get to his rescue ladder. So that's A to B. What I want to show you is that the same proportion we could get from looking at these triangles up here at the top. So if I look at AD in one of the pictures, AD over CA from the other picture is equal to CA from this picture over AB from this picture. If you look at those are proportional. So it's just a way of getting around having to look at them as separate figures and having to draw them and flip them around every time. Alright, so then we're just going to go through the other scenarios that could happen here. So I'm going to put him back at the top here. And we're going to look at what if he fell down CD instead. So if he fell down CD, again, the one he falls has to go across from each other. And then he falls down and lands at that point on the ground. So now he can go this way to get to a rescue ladder, which is AD, or he can go this way to get to a rescue ladder, which is DB. And if you were to look at the triangles up top again, you would see that if we started with AD over CD is over here, that's the ones that match, is equal to CD in the same triangle over DB in the same triangle. So it's just working out the same proportions but with a cute little story instead. So reset, last scenario is he falls down this outside part, which is CB. Again, that's going to go across from each other. If he falls down that outside line, he can walk to the middle line to get back up. That's BD or DB, it doesn't matter what order. Or he can walk all the way to the other side. You have to remember, I didn't make him fall yet. He falls here. So he's still positioned there to get to that other ladder. He's got to walk all the way across here to get up. So anytime he falls down the outside, you have to think about him going all the way across. That's BA. And again, if you look for BD in one of the pictures here, BD is that side of that triangle, over CB is that side, and that's proportional to CB in this triangle over BA in that triangle. So it does set up that same proportion we would want if we separated them, but in a much more fun way. Alright, so we're going to do some practice problems next.